In this problem, we have for complex numbers W1, W2, and W3. Prove that W1 times W2 in parentheses times W3 equals to W1 times in parentheses W2 times W3. In other words, we are basically proving the complex number multiplication is associative, which means that the order does not matter. So, to solve this problem, we know that complex numbers have exponential forms. So we can just let W1 equals to R1 times E times I times theta 1. And this is the form of exponential functions. W2 equals to R2 times E times I theta 2. And W3 equals to R3 times E times I theta 3. Then we have in parentheses W1 times W2 times W3 equals to R1 E to the power of I theta 1 times R2 times E to the power of I theta 2 times R3 E to the power of I theta 3. This will equal to R1 times R2 to the power times E to the power of I theta 1 plus theta 2 times R3 times E to the power of I theta 3. This will equal to R1, R2 times R3 times E to the power of I times parentheses theta 1 plus theta 2 plus theta 3. Now, for W1 times parentheses W2 times W3, this will equal to R1 times E to the power of I theta 1 times R2 times E to the power of I theta 2 times R3 times E to the power of I theta 3. This will equal to R1 times E to the power of I theta 1 times R2, R3 times E to the power of I theta 2, theta 3 times in parentheses theta 2 plus theta 3. So combined, this will equal to R1, R2, R3 times E to the power of I theta 1 plus theta 2 plus theta 3. So we can have W1 times W2 times W3 equals to W1 times parentheses W2 times W3, which shows that the multiplication of complex numbers is associative.